RDF representation of FHIR, putting FHIR in RDF. And I'm reporting on the work of a whole bunch of people, the W3C Healthcare Life Sciences group that's been working on this over a couple of years. A quick note about me, I noticed they put those in slides. If it isn't obvious, I'm old, and I've been developing computer software since the early 70s. I actually ended up learning about this system we got from AT&T called Unix, and we paid them $20,000 for it. They gave us the source code and said never darken our door again. I inherited the job of the first Unix sysop. Done hardware work over my time, but very dated these days. TTL logic and large boards. Worked on a bunch of different standards, all directly or indirectly related with healthcare. ASN.1 is, in my opinion, what should have happened instead of XML, but there you be. 11179 is a standard for metadata registries. It used to be called X3L8, but that X3 made it so you couldn't send email to anybody, and they actually finally changed the group name just so they could continue to send email. 215, healthcare, the object management group, there should be a comma. Health level 7, World Health Organization, SNOMED CT, and I've also had, it's been fun working on TC37, which is the ISO standards group that deals with terminology and terminology. And I've been with the Mayo Clinic. When I say more or less, I had a brief stint with Apple in the early 2000s. So with that, it made me think of this old Gilbert cartoon here. One of those condescending Unix users. Yeah, mostly spammers in the beard. Yes. Okay, we're going to talk about RDF, and I realize, bear with me, a lot of you have experience with RDF, but if nothing else, this is being recorded, so I can't make any assumptions about the audience. And then what we've done in FHIR, talk about something we're still trying to come up with a good word for. We're calling it the FHIR Metadata Vocabulary, but everybody's eyes go glazed when we say the word metadata, so we're working on a different word. A schema language for RDX that's been developed, and kind of where we are. Okay, the resource description framework. As they say, it's the standard model for data interchange on the web. And if you look at it, it's about as simple a model as you can get, which is what allows it to facilitate data merging. The idea being that you have disparate sources scattered over the web that may not even know about each other. And how do you get all this information together so that you can aggregate your knowledge? It's based on URIs, we'll talk a little bit more about that, and forms directed, labeled graphs. I'll have links through here where I've got the sources. This comes from here. So informally, this comes right out of the RDF primer. You have the notion of the names of people, things, places, ideas, paintings, what have you. And then you have predicates or facts about these things. So we've got the notion of Bob. Bob is a type of person, and that's a thing too. Bob was born on, and this is a date. This is text. A friend of analysts interested in the Mona Lisa, and etc. And these facts could be scattered across the web, but the RDF model allows you to put it together. And it's in the form of triples. So informally, I can just say Bob is a person, and that's a full statement. He's a friend of Alice, I was born on, etc. And I can make statements about, I don't have it here, Leonardo da Vinci. Now that's interesting, I said was created by, and I put this arc in the other direction, but same thing. And the video is about Mona Lisa. So it's just gathering all these little facts together. RDF has three types of things, three things that are building it. We have names, and being the World Wide Web that put this together, surprise, they use URIs for names of things. The advantage Well, there's all sorts of ways to form URIs. The typical form is the HTTP URIs. And the advantage you get out of that is there's the Internet Name Service, the DNS group, that you register your names with them, w3c.org, schema.org, xml namespace.com. And because they take care of registering it, you're guaranteed that at least the first part of your identifier is unique. So these are just some sample URIs, both for things and for predicates. I mentioned IRI in there. You hear that word more and more. The web's gone to that. And that's, an IRI is a URI that you can do in different languages, kanji or what have you. There was a period of time when if you wanted to look up a Chinese website, you couldn't type in Chinese to get at it. These days, URIs can be full Chinese, and that's what IRI means. Okay, the second type is literals, and it's just things like strings, or strings plus languages, or you have the notion of type strings, which enforces a format. This is a type date, this is a type integer. One of the interesting things you'll find about RDF that turns out to be very annoying is that these are implicitly disjoint, date and integer, which makes sense, but also integer and float are declared as disjoint. So in the RDF world, 42.0 is an entirely different thing than 42. So we have the triples, and when you're forming an RDF triple, the subject can be either a URI and a blank or a blank node. We'll talk about blank nodes in a minute. The predicate has to be a URI, and the object can then be either a URI, which references or can reference something else, is the name of something else, or the literal, or again, the blank node. So, as an example here, I've got Bob is a person. So this is the URI that somebody's assigned to Bob. This is the URI that the W3C has published in a namespace called RDF, which is the type predicate. And here's a URI that comes from the friend of the friend group, and it's actually becoming kind of the default name for people and mailbox and relationships. So if I wanted to represent this art, it would be these three URIs. And if you have literals, it's the same thing. I've got Bob again as the subject. I pulled birth date from an interesting catalog of URIs, and that's a theme that I'm touching on because it's kind of important. And then down here I've got a literal that's got Bob's birth date on it. Blank nodes. When you start putting all of these things together, having to assign URIs to everything, if you worked in databases that are that way, you end up just concatenating a bunch of stuff together and building URIs for the item in the background of the Mona Lisa, or the person who hit me, etc. Just doesn't work. So they have a third category, which is called a blank node. And you can assign it a local identifier, but it's not a URI, and most important, it's not an identifier. It's a thing you can put in locally. So as an example here, I can say, okay, the subject, the Mona Lisa, and it shows, and then I've got this thing here, it's just a little notation, and what comes after the colon can be anything I choose. It's for my local graph, it's something, and then I can say something is of type Cypress tree. And this something is local to this representation. The next time I show this to you, this might be something, this might be an entirely different thing. And in fact, what's interesting is that to be conformant, Sparkle engines have to guarantee that these change. If you run a Sparkle query, which a little advanced, I know, but you find out things about the Mona Lisa, and you get a blank node back, if you go back into a Sparkle engine and it conforms to the W3C spec, it'll say, I don't have a clue what this is. The only way that you can relate the Mona Lisa to the cypress tree is to run a query in the form that says, find everything that the Mona Lisa shows, and for that, give me the type, and you have to run that as one query. Periodically, various people try to come up with words like skolemization and how can we name these dang things? And the answer is pretty simple. If you wanted to name them, you should have named them. That's why we have blank notes. Okay, the other bit here is the RDF turtle notation, which is what we use. This is something that's a bit of a confusion on the FHIR website because turtle is sometimes used as synonymous for RDF. Turtle is one way of representing triples. There's many. N triples is just the raw form. There's an XML format that they came out with originally that people try to avoid with a passion. What's interesting is there's actually a JSON format now called JSON linked data that allows you to look at it simultaneously as JSON and RDF. And one that is really handy to use is the turtle notation. So the simplest form, subject, predicate, object, followed by a period. Or you can say subject, predicate, object, predicate, object, predicate, object, following them by semicolons and closed out with a period. Or subject, predicate, object, 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 object. So the first one's that. The second one you get, it's equivalent to object 1, object 2, object in, and then the third one here. So that's the other bit that makes it a lot easier is that you can assign prefixes. This is much like XML schema or XML. So I can say wherever I see EX colon, it's the same as this URI. And by the way, full URIs are inside the less than, greater than signs. So I've assigned 3 prefixes. You can also have the default prefix, which is just a plain colon. So these are 2 turtle statements that are equivalent. I can say EX, which goes down to the hash, Jim is of RDF type FHIR patient, or because the colon prefix happens to have exactly the same URI as EX, I can just say colon Jim. One nice feature they gave you is you've got a token for RDF type. It's the one special token. It's the word A, which means is a type or is a. So I can say Jim is a FHIR patient. And in both cases, what I'm doing is making this statement right here. Okay. Oh, and blank notes. This is interesting. The RDF turtle notation allows you to conceal a whole bunch of sins of blank notes with these nice little square brackets. So if I say subject, predicate, open square bracket, and then a bunch of predicate objects, close square bracket, what I'm actually saying is subject, predicate, blank note identifier, and then blank note identifier, predicate 2, object 2, predicate 3, object 3. And it should be not pretty, but predicate here. Same sort of thing here, showing a little. So those square brackets make it look a lot more like just any other language. But you still have to remember that when you got the triples, you've got all those blank nodes in the middle. Okay, the good news. It's a minimal structure, subject, predicate, object. And the principle behind the web is anybody can say anything anywhere. So I can make statements about Bob and about the Mona Lisa. You can make statements about it. We can put it all together. The other thing is you've got 2.5 data types to learn. The IRI, the literal, which has there's a bit of structure embedded in it, the various types. It comes from XML, and you have to learn a little bit about, especially dates and times get complicated. We have HL7 to thank for that, by the way. That was their contribution to the XML schema. And I say 2.5 because we have the blank nodes, but again, they don't have identity. That's the good news. The bad news is it's minimal structure. Anybody can say anything anywhere. And if you're taking care of patients, you may not want that to happen. There's no rules. Just because you say somebody has a first name doesn't mean you're going to find a last name out on the web. Unless you agree on some rules to begin with, you end up with incredibly defensive programming. What do I do if this bit of information isn't there? What do I do if that isn't there? How do I default this? The other bad news is anybody can build URIs. It's really easy. And if nothing else, there's a URI format for the UUIDs you get on your Microsoft machine. So, You know, I can mint you a million URIs a second if you want them. But this is useless until we agree on the names of things. If Bob decides he's company.org/Bob Gleason and I decide he's bob.com/Bob Gleason, nobody knows we're talking about the same thing. If you come up with one URI for the Mona Lisa and say something about it, and I come up with a different URI, we don't even know that we're talking about the same thing. So you can't get anywhere until you agree on the meaning of URIs. Now that's the bad news, but that's also the really good news because it makes that problem apparent. Nothing works until you get this little agreement on the names of things done. And it forces you to get together. So we have URI catalogs out there. Some of them are just well known. RDF and RDFS is used in most anything you say in RDF. You have to know about these. There's the XML schema data types, the web ontology language. You'll find the Dublin core out there, which is a catalog of identifiers for provenance and dates and creation and what have you. A simple knowledge organization system for assigning labels and definitions and notes and what have you. Front of the hand we saw some that are kind of coming in ad hoc. DBpedia, which is as far as I know, actually drawn from MediaWiki or Wikipedia, and it's got RDF stuff in here. And most interestingly, FHIR. Is the process of doing RDF for FHIR, we have a catalog of URIs for clinical data. Okay, this is a slide that I took from, well, I can't quite see it down here, but this was Michael Lawley's Advanced Terminology Services yesterday. And he was talking about the real problem. We've got clinical data over here in JSON and XML, and it's got codes in it, and somehow we've got to join this with terminology. One format, a second format, or if even they're the same format, two different record structures. And so all this is closure and the work you have to do to put all this stuff together. You put it in RDF, SNOMED CT is already in RDF. Link is available in RDF. RxNorm is available in RDF. And every FHIR resource you can get is available in RDF. You can put them together, and as long as you've agreed on the same name for things to begin with, you can just start going, or just start working with it. This is in here just to make you aware of it. I'm a Python geek, so there's a couple of slides in here about a really great library called RDFlib that's maintained by the RDF people and allows you to load and manipulate and export graphs. So just be aware that there's things there, and if you like doing exercises, that's a fun one to play with here. Okay, so that gets to the main subject here, FHIR and RDF. It came out in STU3. It's still for trial use. And what it's got inside it is tools to go from the FHIR model structure into RDF and from RDF into the FHIR model structure. It's got a tool that takes the structure definitions, the FHIR definitions, and turns them into shape expressions, which I'll talk about in a minute. And it's got something that takes all of the resource definitions in FHIR and turns them into a FHIR resource catalog, metadata vocabulary. Graham wants to call it the FHIR ontology, but we discovered Wednesday that it was a good thing he didn't, because he thought the ontology makes you think there's all sorts of good stuff in there. It wasn't. So we'll call it the ontology again once we get the stuff Graham wants back into it. Okay, if you go to the STU3, which you can just now get off of the hl7.org website, if you go into any resource, you've got the examples over here, and on the right-hand column, you can pick term, so you can see what any of these resources look like in RDF. And here's the same resource in JSON and RDF. So one of the things that we have changed slightly is resource type, which is a FHIR URI, isn't recognized by the or by the people on the web. So we've changed that into the RDF type we talked about here. So this is a resource, its type is observation. Here's the ID. There's a B node here, we'll talk about that in a minute, but inside is the value of example. And here's an observation status, and its value of final, and encoding and what have you. So this is the canonical RDF representation for that resource. All right. Now, one of the requirements for this group, and it was a sensible requirement, is that the FHIR structure definition had to be completely round-trippable. We had to be able to go from FHIR to RDF and not lose anything and not add anything. We had to be able to get back here and have exactly the same thing. So us RDF users would be really, really happy if the person.active is a type Boolean, and just be able to say active, true, Boolean. That's what the web is looking for. Instead, we've got this strange B node here, active B node. And B node has a value of true Boolean. The reason for that is while the normal thing you see out here is just active, true XSD Boolean, everything in FHIR is extensible, one of the messages that comes from way back. So there's nothing that prevents somebody from putting a certainty extension onto the Boolean type. And all of a sudden, instead of just being a simple value of true, it has a value of true, but then it's also got a 0.75 certainty. That if you know how to process, you can deal with it, and if you don't and it isn't a modifier, you can ignore it. But what they wanted to have happen is that the processing, what you did for this and what you did for this was the same, whether the extension was there or not. So that's why you find all those B nodes in there. There are times when we may end up creating an alternative, non-extended format at some point to make it easier to use, but there you are. Okay, some of the other things we had to do to make it round-trippable in a JSON or an XML document. It's a hierarchical structure, and the document root is the outermost node. When you've got a list of triples, it's not obvious what the outermost node is. And a note, while you see B nodes in here, there's nothing that says these have to be B nodes. I could say the resource ID is URI X, and I could say X FHIR value F201, and it would still be entirely legitimate. So I have no idea whether F201 or X or something else is where I start if I'm going to turn this back into JSON or XML. So we've added something called node role. There's only one role right now, tree root. And when you find a tree root, this says this is if it says that this subject is the outermost node of a document. The other thing is, while RDF has a list format in it, or a collections format, it was developed by the list people, and if you like Cotter and Cooter or first and rest type processing, it's great. It gets very annoying if you're dealing in OWL or Sparkle or a lot of other tools. So there's been alternative ways of putting together organized or ordered lists. And the way that was chosen by this group is fairly standard. Basically, when you have multiple occurrences, you can put a FHIR index and an integer that just gives you the relative position inside here. So here, over here, I've got two codes, and because this is JSON, the JSON lists are already ordered. I have to put on index 0 and index 1 out here to preserve the order. A handy thing is, even if it's a single entry, we go ahead and put the index on there. That helps in a lot of other situations when recognizing that it's a list versus an individual. Okay, a couple of other things we did that don't add information but are terribly important is in JSON, when you've got a code that FHIR doesn't actually tell you how to form the URI for concept code in Snowman. I mean, they talk about it a little bit, but what you get is the system SCT in the code, and if you're particularly clever, what you discover is, well, if the system's SCT in the code, I form the URI by saying snowmed.info/ID. You will know concatenating the system with the code does not give you the URI for the Snowmed identifier. And this is published by Snowmed International. It's not just a capricious decision. There's reasons for that. So you have to put a bit of software around here if you're actually going to access Snowmed via its URI. While at the moment in the spec this is optional, we've said when you're turning this into RDF, it would be really dang handy if you could give us an RDF type in the actual Snowmed code. Because if you don't, in the RDF, we're going to have additional knowledge about what to do with this little thing here. If it's over there, then you can use things right out of the box and start doing interesting stuff, which I'll show in the next talk. The other thing that's turned out to be a major problem is when you have resource references, there are rules on how you take patient F201 and where you got the resource and various other things. To be honest, I don't know all of them. And turn it into a resource URL. Again, that's software that has to be somewhere if you're going to actually generate a subject for something. So what we've done is when we generate the subject, you can optionally put in a thing called FHIR link, and it says this is the URI for this resource we're referencing. And that would be the subject of another RDF graph. Another thing that is extremely frustrating about how FHIR is put together right now is that on a diagnostic report, a subject can be a patient, it can be a device, it can be a bunch of different things. And while FHIR sort of kind of has rules that say, well, you can parse this URI, and as long as it meets a certain format and it's got /patient in the middle of it, you can assume, you're not guaranteed, but you can assume it references a patient. What we've done in the RDF, just because it makes it incredibly more useful, is we've said, okay, when you're generating the RDF, if you know what this is supposed to be or what it is, tell us. Because otherwise, if we're going to be doing reasoning about patients with diagnoses, we don't want to be dealing with devices with diagnoses. I don't even know what that means. But there's no way to tell short of generating a URI, dereferencing it, and if the server is there, and if the server responds, you can find out whether it's a device or patient. So again, this is optional, but by putting the resource type in there, you get that information. The one other thing you're going to find in there, this is one of the hole in the bucket dear Lysa problems, is if we're going to be using this RDF in description logic reasoners, which we like to do, we have to import this URI catalog. If in my particular FHIR resource, I just have all those predicates and I don't import the URI catalog, it assumes that everything is an annotation property, and that's no good. I have to have this catalog present. RDF has no import mechanism. There was quite an argument about it, and they just never got that one resolved. So on the web, if you want to import something, you have to use the OWL imports mechanism. And if you want an OWL imports mechanism, you have to declare something as an OWL ontology. So yeah, no import, so we have to use OWL. We have to have an ontology. We can't just give the ontology the same name as the resource, because declaring that something is simultaneously a FHIR patient record and an ontology doesn't work. It's a FHIR patient record, not an ontology. Right. And by the way, stay tuned, because we're playing around with both URIs and content negotiation. So this import format may be changing a little here. Okay. Accessing FHIR RDF, we have the MIME types, which is text turtle, and we're going to try to get some others in there. And the spec says you can have TTL turtle, text turtle. At the moment, The only one you can be certain that works is text turtle. These are the servers that sort of kind of support it. We're just starting to get it out there. We're really hoping to get it into the Happy server and ideally into the simplifier as well. Just an example, if you want to use curl, this is one way to do it. This is Graham's server, and if you say underscore format equals text turtle, you get that back. You can also use the -H option and say except text turtle. It does exactly the same thing. In your browser, this is at least Firefox. I can actually go out here to my accept header and add text turtle in as something like that. And then if I go here with that, I can also get the RDF back. So that's another way to do it. Another thing to look at, just be aware it's here. Hopefully some point this can disappear because all FHIR servers will have RDF. But this one, if you point it at a URL that has JSON on it, it'll return FHIR RDF. You can use it both as a command line server like this one here, or you can, if you have Python code, it's a library you can pull in so that we use it in the project here. Okay, this is the FHIR resource catalog. You can just pull it off of fhir.ttl, all the namespaces, and what it does, it's just a proper, I say very proper, there's a whole lot in structure definition that isn't in here, but its job in life is to declare the classes and predicates. So in the resource catalog here, I've got FHIR observation, and it's declared to be an OWL class, so we can work with it. It has a restriction with a cardinality 1 on observation status of type code. So this essentially says that this has to have exactly one, or this has exactly one. Important not to say has to. Has exactly one observation status of type code. And if you go down and look at observation status, you can get the domain and the range. So observation uses it. If I've got it there, it's type code, and you also get a little bit of the documentation there. You can load this into Protege, sort of. At the moment, though, you get this missing import thing. We're going to get this fixed. The short-term copy is you got to download, or issue, you got to download it. Let's see. If you go to this GitHub site here, we have a copy of fhir.ttl and a whole bunch of stuff. And this tells you all about how to load fhir.ttl and what have you into Protege. We're also going to have, our next talk will be on that as well, so that you can actually look at the FHIR catalog in the Protege browser. Be very aware that an OWL ontology is not a schema. It's not the same thing as XML schema. If, for instance, I say, okay, the ontology says that observation status, the domain of it is FHIR observation. That's not saying, okay, if I say I've got a tire iron manual, bad example, that's a FHIR device, and I say its observation status is final, that's not an error. If you put that into a reasoner, what it does is it concludes, oh, it's also a FHIR observation. Because I said it. I said the domain's FHIR observation, therefore if I use it, and there's no error here. Now, we could go in there and put in another rule that says observations and devices are completely disjoint, and in that case, then it would say, oh, there's nothing I can do, but not everything's disjoint. Persons and patients, for instance, aren't. Another thing here, I say it has exactly one status, so if I say it's a status preliminary and a status final, you'd think it'd say it's an error. Those are two statuses. But in the RDF OWL world, it says, oh, well, for this to work, the thing named final and the thing named preliminary have to be the same thing. So again, the idea is that this tells you about the world, and reasoners say, is there any possible configuration that you haven't ruled out that can make all of these facts true? And so, well, one configuration is if preliminary was final, this would work. So, yeah, and another one here is if you have no properties at all, it says, well, that's great. I know somewhere out there there's a status on this observation. I don't have it, but I know it exists, and it'll tell me it's there. So, What we've got here is something that's called Shape Expressions. It was developed by the W3C, and it's been a component that's desperately needed. It's a way of saying what can I declare will always be true about a collection of RDF triples I have, or another mode is to say, is this collection of RDF triples, does it conform? It's called Shape Expressions. It's RDF schema, but RDF schema ended up being used for something else that isn't an RDF schema, so we had to call it Shape Expressions or SHEX. And be careful, because the number of puns that come out of that are close to FHIR, but they're not near as clean as FHIR. All right. SHEX schemas are available for all the STU3 resources. If you scroll down to the bottom of the resource definition, you can click on SHEX here. You can get the Shape Expressions declaration. That is the equivalent of what's in the structure definition, with a couple of exceptions we need to get in slicing and constraints aren't. There's a couple of SHEX validation tools out there. There's also a Scala library, and if I get my job done, there will be a Python library. There's a JavaScript library. This is just an online tool. You've got the URL, and what I've done actually is this examples.json has a couple of samples of observations and the shape expressions, and you can validate it. This is another one written in Scala by a different group. So this is fun to go out and play with, learn how to use shape expressions. So, where we sit, the STU3 specification has the format. It's starting to become available. We need to work with content negotiation. In the short term, at least we have a Python tool, and maybe we'll get some others. Michael van der Zel in the front row has a .NET tool for emitting RDF as well. It includes the FHIR URI catalog, metadata vocabulary, or what have you. It's standard URIs, and as I mentioned earlier, for RDF to work, you have to agree on the URIs. This is really interesting because this is published by a standards body, HL7, and it's a collection of URIs for most anything you're going to say in the healthcare domain, patient identifier, diagnostic status, etc. So this is really, I mean, potentially Lloyd wanted me to, because FHIR itself is still just a draft standard, be careful about saying too much too quickly, but on the other hand, it's terribly exciting. And we have the shape expressions there that are for validation. One thing I didn't mention here, but shape expressions also can be a mapping language that can transform RDF to RDF or RDF to anything. Essentially an XSLT for RDF. And credits, actually Dr. Gochin Chong just walked into the back of the room, and this is done on some of his grants here and some of the contributors. And I made it with 2 minutes to spare. This 40-minute, actually I think it works out pretty well. It forces you to be succinct. Questions, comments? Yeah.
I have one question, and it was earlier when you showed the URIs in RDF versus the coding system and code in FHIR, basically.
Mm-hmm.
What I saw is that you write in the TTL that they are an instance of a.
Yes.
But then afterwards, you also write down that they have this coding system and this code, right, which is in some way redundant, let's say. But is it to keep for now backwards compatibility or compatibility with FHIR, or? This
comes to the next talk. I guess we have a 5-minute gap, and we'll show how we start using this. Using the RDF pipe, oops, wrong one.
Yeah.
I need to back up a little more. That's not contentious.
Yeah, that one.
Okay.
Yeah.
This RDF pipe,
yeah,
is contentious, but it turns out that I think it's going to serve to keep the FHIR community honest. Right now, when we're putting in value sets, we can take a guess, but for instance, let's see, well, this is just radiology, but if I've got a code in there for a malignant neoplasm, and I say this is a diagnosis, and its code is malignant neoplasm, That's not a finding of malignant neoplasm. I mean, if I just put in the definition, I say, this diagnosis is malignant, that's wrong. And there is a code in SNOMED that says finding of malignant neoplasm. So it's our hope that actually this type arc is going to be one of the things that can allow us to start to quality check the value sets to make sure that we're, because otherwise we're going to have this fellow named Barry Smith coming down on us. And I don't know whether you've ever run into him. He's the king, philosopher ontologist. And if you say you have an ontology and you say something foolish like this record is a malignant neoplasm, he will come down and tell you that you're very wrong. I mean, it's a good thing, but it's kind of embarrassing when Barry Smith arrives on your doorstep.
So you want to keep the distinction to make sure that at least in RDF you can make the right, well, let's say not judgment, but instance regarding what's written in the FHIR message, right?
Yeah, and one of the things we have to do in FHIR is we do have to actually go through all of these and say what should the URIs be, and I think it's time that we just did the whole thing. The other thing is that bit of information isn't just useful in the RDF space. So we'd like to, we've been thinking about having a linked open data profile for FHIR that adds a few of these things as extensions and gives everybody access to it. So that'd be it. We're out of time. And in 5 minutes, I guess, we run and get coffee. And then the next talk will be how some of the ways we're actually using this today, or start with.